So let's talk about percentage increase and percentage decrease. Okay, so we're going to use the same example, right? Suppose the rent went from $900 up to $999. What was the percentage increase? So it's kind of like looking at the same example we did, but flipping it backwards. Instead of saying, I know the percent increase, what is the dollar increase? This is saying, I know the dollar increase, what is the percent increase? Okay. So, I've already sort of structured how to do this, so we'll just kind of go through it really quickly. Okay. The steps when we want to find a percent increase is to first find what is the actual increase. Okay. So we want to consider how much of the increase there was, right? And that's going to be the difference. So going from 900 to 999, if I subtract, I get a $99 increase. Okay. So this is the amount of increase. Okay. Since the amount of increase is $99, if I want to find the percentage increase, what I need to do is answer the question, 99 is what percent of 900, right? So I have this $99 increase. Since I want a percent increase from 900, I want to know what percent that is of 900. So you can see how we're building up the process of how to solve this by sort of just talking it out and then translating what we talked out into math equations. Okay, so I want to answer this question. 99 is what percent of 900? Okay, so again, I translate the 99 is equals, what is my unknown? Percent of means multiply. So 99 equals 900 times x. So I can see, okay, there I divide. So I have 99 over 900 equals x. When I divide, I get 0.11 or 11%. Okay. So going from 900 to 999 is an 11% increase. Okay. Now, if you wanted to just like write down and memorize a formula, right? If we were to look in a book and say, how do you find percentage increase? Okay. Percent increase equals, you could say the ending amount minus the starting amount divided by the starting amount. Okay. Now, the reason that I don't like this is because when I look at this formula, it doesn't make sense to me. Like, I don't know why do we do that? Why do you divide by the start? Why not divide by the end? Why not divide by the middle? So sometimes I find formulas don't really tell you the story of what's going on, but like when I went through this process, that sort of did, right? So why do we have ending minus starting amount? Well, that's the amount of increase. Why are we dividing by the starting amount? Well, I want to find a percentage of how much I had to begin with. And if I have a number is a percent of something, to solve for that percent, I end up dividing, right? So that's sort of where that comes from. Okay. Now, we're not going to work with this so frequently that you have to like memorize a formula or anything. Okay. What I really wanted to do was sort of have this breakdown for you. I think it's more useful to be able to break down a situation you don't know and figure out what to do than it is to remember a formula. Okay. So let's do some examples where we use that. The population of Chicago was 282. That shouldn't be Chicago, that should be the US. The population of the US was 282.2 million in 2000 and 331 million in 2020. Find the percentage increase. I was going to start with a population of Chicago, but it turns out it didn't increase. It actually went down by a small amount over that period of time. I'm like, that's weird. I'll just use the US. Okay. So once again, what I want to do is pause for a second and let you try this one out, see if you can solve it, and then we'll go through it together. All right, let's go ahead and go through this one now. So we have the population of the US. We're starting with 282.2 million. And we're ending with 331 million. Okay. You can just think of million as being your units. You don't actually have to write the extra 6 zeros after our numbers here. Okay. So what we can do is first find the increase. And that's just the difference, 331 minus 282.2. Okay. So when I subtract, I get 48.8, right? Where my units are millions. Okay. And then we want to say, okay, 48.8 is what percent of 282.2 million? Okay. So 48.8 equals X times 282.2 divide. So we get 48.8 divided by 282.2 equals X. Okay. And when I divide those, I get 0.1729270021. It doesn't come out to like a nice, neat terminating, decimal, right, in short order. So I say, okay, first I want to convert this to a percent, and then I probably want to round this a little bit. Okay. So we could say, okay, maybe if I round to a couple decimal places, if I move over to, I'll have 17, maybe 0.29, and I can write that as a percent. Some of you might have rounded to 17.3%. Maybe you just wrote 17%. 17% feels like it's maybe rounding a little bit too far. I like to, as a general rule, think how much rounding seems reasonable, and then go at least at 1 decimal more than that, right? So. Okay, so over the 2 decades, we had a 17.29% increase. Okay, so let's look at example 10. Example 10 is going to be very similar, except that our ending amount is lower than our starting amount. So instead of a percentage increase here, we're going to find a percent decrease. Okay. So the amount of decrease if I take 28,000 minus 23,800, I get 4,200. And then I say, okay, 4,200 is what percent of 28,000? So to solve this, I'm going to divide by 28,000. Okay. And so I get X is 0.15 or 15%. So here we have a 15% decrease. Okay, suppose instead of doing this by writing out all of these words, I just used the formula. I said, okay, if I want to find a percentage increase or decrease, okay, I say, the percent is going to be the ending amount minus the starting amount divided by the starting amount, right? That was the formula I wrote down. So I plug in my numbers. So we have 23,800 minus 28,000 divided by 28,000. And I'm going to show you this on my calculator. Okay. In order to do that all at once, when I write this numerator, if I just type this in my calculator is going to do division first. I say, no, I want the subtraction first, so I have to make sure I put that in parentheses. Okay. So we have 23,800 minus 28,000. Oops. Okay. Divided by 28,000. Okay. And my calculator gives me a negative because when I use this formula, right, we didn't really, where is it? Here it is. We didn't really distinguish, right? We sort of wrote this formula for a percentage increase, and we didn't distinguish between a percent increase and decrease. Okay. And so a negative just indicates that you have a decrease instead of an increase. But I still get the right number. I still get that 0.15. Okay. So here we get negative 0.15. So I have a negative increase, which is a decrease. Okay, so it's just another way to kind of, go about the same thing. All right, any questions? Okay, well, the good news is things kind of ramp up pretty quickly, but I think these first few sections aren't too bad. What I'm going to do is spread them out a little bit, though. So what we're going to do, our first week has these 4 sections. We're just going to go through 1 section per day. So today we went through percents. Tomorrow we'll go through simple interest, and then we'll move on to compound interest and effective rates. Yeah. So what I'm going to do is I'll post the recording up today. It takes like a few minutes to process and then upload and things like that. So I should have it later on this morning, but early afternoon at the very latest. So yeah, every time we do a recording like this, I'll always post it up